Tonight, our speaker is Kenneth Reitz. Is that how you say it, right?
Yes.
Yes. So Kenneth is a very well-known speaker in the Python universe. And he was just telling me that he was just last week at DjangoCon EU in Poland. So he is in demand worldwide, and we are very lucky to have him here tonight. Kenneth is the author of a well-used library called Requests, which you may be using in your own projects.
Thank you.
I like that the code got applause before the guy got
It's always a good sign.
Requests is a very well-loved library, as you can see, for doing things that URL-lib does, but it does it in a nicer way. And Kenneth's talk tonight, called Python for Humans, is based around the things he's noticed about designing APIs, and a lot of it has to do with requests. So let's give him a big hand.
So, hello everybody. My name is Kenneth Reitz. You can follow me on Twitter at Kenneth Reitz if you'd like. And I come from a company called Heroku. Heroku is basically a really great platform for deploying applications that are written in Python. And if you want to talk to me more about that later, I'd be happy for you to, especially while we're enjoying free beer. I'm also a member of the Python Software Foundation. And if you know what I do, or if you're familiar with my work, it's probably from the open source that I do. I wrote a library called Requests, which is HTTP for humans. Basically, it's really hard to get to send HTTP requests in Python, and I tried to make that as simple as possible. But we're going to get into that in a minute. I also wrote a project called httpbin, which is available either to install yourself or at httpbin.org. Basically, it's really hard to test HTTP libraries and clients. So if you're like working with curl or like some JavaScript thing, basically all these different libraries and tools are going to send different headers and other things like that when they're operating. And this tool allows you to debug that and analyze it. So like accept headers, for example, that's like different in curl than it is with URLlib2. So if you use this tool, it'll allow you to like kind of get a good idea of what's going on. And we can ask it for like a 304 or a 404 or some kind of weird authentication scenario, and it'll respond. I also wrote a project called Legit, which is a Git workflow utility for the command line. Basically, it's the workflow from GitHub for Mac brought to the command line. So like if you're working in different branches and you switch between them a lot, you don't have to like stash and unstash and commit changes that aren't ready yet. It'll do that automatically for you. Envoy, which makes processes easier, and a bunch of other stuff. OS X GCC installer is pretty popular. It makes Apple's lawyers very upset. But we're on good terms now. So as I do all this stuff and I write all this code, I really try to I love open source. It's like totally changed my life, and it affects me every day, and I think it's amazing. And I try to open source everything in my life. I've gone so far as to actually open sourcing my genome. I got my polyface, I believe it's called, from 23andMe in a text dump, and it's available on GitHub. So you can fork me or something if you want. I have a pull request now for improved metabolism for caffeine. So I'm a work in progress, I guess. As I work more and more with open source, I realize when I'm working in an internal code base or like something proprietary or secret, something that's only for me or my colleagues, I realize that if I pretend that the project is open source, there's a lot of really good things that start to happen. Components start to become concise and decoupled from one another. You're not going to be using an open source project if it solves like 30,000 problems. Usually the best projects that we use solve 1 or 2 or 3 problems really, really well. Kind of follow the Unix philosophy. Concerns separate themselves from one another. A lot of best practices will emerge in your code. For example, if you're going to be building, like say, a website and you're going to be pushing it up on GitHub for everyone to see, you're not going to put your database credentials into your code base. So you shouldn't be doing that internally either. And I know none of us do that, ever. Documentation and tests become absolutely crucial. You're not going to be using an open source project if it doesn't have any tests or any documentation. So you shouldn't be using that for your internal code either. And another side benefit of this is that if you ever do want to release your code as open source, you can. Just flip the switch. You know that you've already been building it that way all along. There's nothing you have to check. So who here uses Python? Woo. Excellent. I like this crowd already. We all come to Python for various reasons, and I think it's all about philosophy. We all share this really dark, evil, depressing past We come from different languages like Perl or Java, PHP, Cold Fusion, COBOL. Lots of terrible, terrible things. And there's all these things that attract us to Python from those languages that those languages lack. And this is all kind of consolidated in this thing called PEP20, which is available at any Python interpreter. You just type import this, and you will see 19 small little bite-sized chunks of what the Python philosophy is. And we're going to go over some of those today. This is one of the most obvious ones when you're looking at Python syntax, and it is that beautiful is better than ugly. If you look at a lot of other languages, there's a lot of syntax that is added that has been removed in Python. You have things like curly brackets. Well, that's all you need to know, curly brackets. That's the biggest one. There's a lot. Explicit is better than implicit. If you're working with a lot of languages like PHP and Ruby, there'll often be like little $ things that are just kind of available in the namespace that you don't know how they got there or where they were defined. In Python, we try to make everything as explicit as possible. So you're going to import something into the local namespace, and then you'll be interoperating with it. Of course, you can do some crazy things in Python too, but those are frowned upon by everybody. Simple is better than complex, and complex is better than complicated. If the implementation is hard to explain, then it's a bad idea, unless, of course, you are PyPy, because no one except for Alex Gaynor can explain PyPy. And this is the one that we're going to touch the most on today, and the most important one, I think, for us as a community. And it is that there should be one, and preferably only one, obvious way to do it. A lot of languages like Perl or Ruby really kind of they put a lot of focus on expressiveness, which to them means that you can, take a problem and approach it in 100 different ways. And in Python, we try to do the opposite of that and only focus on one obvious way to do it. That doesn't mean that there aren't other ways to do it, but there's one way that should be obvious. That's the only one that should be the default. So you just learned, or you decided that you want to learn Python. You're coming from like Ruby or something like that, and you finally found a community that actually like gets you. Welcome to paradise, right? Like we have all these different things. It's right into the standard library. You just do import this, and you get all of these great things that you've always wanted your language to do. It's going to be awesome. Unfortunately, that's not always the case. So I'm going to show you why. So we're going to pretend that we know Ruby, and here's like a simple kind of hello world, real hello world type of scenario here. We're going to be sending a simple request to GitHub with their API, with our username and password attached, and we're going to get a response. And then we're going to try to port this code to Python, because that's kind of a simple web services-oriented hello world. So in Ruby, the first thing you do is you import a library called net/http and a library called URI. You then parse the URI, call it URI, get a reference to it. Then you create a new network connection, new HTTP connection, with the host and the port from the parsed URI. Then you tell the connection to use SSL. And then you create a new GET request with the URL. You add your username and password, and you get a response. It was very verbose. It was very verbose. And it's not the cleanest thing in the world, but there's nothing here that is unexpected. Everything here is obvious, and everything here isn't overly cumbersome. So the first thing you're going to do when you try to port this to Python is you're going to ask yourself, what is Python's version of the net HTTP library? And you're going to find a myriad of answers online. You'll find something called HTTPlib. You'll find HTTPlib2, URLlib, URLlib2, URLlib3. And several hours later, what you're going to find is that the prognosis online seems to be that you need to be using URLlib2. So using the official API and following the documentation and everything, this is going to be the code that we end up. And let's go through it here. So the first thing you do is import URLlib2, and you get your URL, and you create a new request object from URLlib2 with that URL. And then you create a you instantiate a new HTTP password manager with a default realm. Store that as a password manager. And then you add your password with reference to the URL, username and password in it. And then you create a HTTP basic authentication handler from the password manager, called an auth manager, and then you install you create an opener from the auth manager, and then you install the opener, and then you can open your URL and read the result as a socket. What the hell? That's the most complicated and convoluted thing I've ever seen. And it's actually much worse than that. So the GitHub API, by default, if it's asking for a protected resource, like let's say you're asking for data on a private repo, instead of asking for credentials with a 403, they respond with a 404, which kind of is like, I don't know what you're talking about, instead of let me see ID. So they don't want you to be able to guess people's repo names, basically. So to override the behavior, even though we explicitly told it to send a request on that, to send our username and password on that request, we have to add all this code. And this is the shortened version. If I was to really do it, it would go all the way down to the floor. And that's not fun. So admit it. If this was you, and this was your first interaction with Python after using Ruby, I think you'd leave and you'd never come back. This is not what we are all about, right? Our philosophy, we stated very clearly that we have all these beliefs and all these things that are important to us, and we failed in every single one of those areas. It's unclear which module you're supposed to be using. There's no obvious way to do it. The prognosis seems to be URLib2, but once you get there, the docs don't actually tell you how to do much of this stuff, and the API leaves a lot to be desired. I think that this is a very serious problem. HTTP should be as simple as a print statement, because web services kind of build the whole world around us, right? Like we're building all these tools that are being talked about on the news every day. Like right after someone gets elected, they're like, let's look at the tweets. All these tools are all built around HTTP, and that's super important. And I think a lot of developers, when getting started, or even in their day-to-day lives, if they're doing this every day, they're all going to be working with HTTP all day. So the solution is simple. I think we need to build elegant tools to perform these tasks. And I like to call these pragmatic packages. And I think Python needs a lot more of them. Pragmatic means dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. I like to call this Python for humans. So let's break HTTP down. What is it at its core? Basically, it's a fairly simple system when you get down to the heart of it. It's a small set of methods with consistent parameters. You have get requests, head, post, push, put, patch, delete, and all of them accept headers, URL parameters, body, and form data. URLib2, on the other hand, does not follow any of these patterns. It's very engineered. You only have access to a get request, and it kind of automatically turns it into a post if you add extra data into the request. The docs are really hard to read, and this really scares people away from Python. So enter requests, which is HTTP for humans. So to do this exact same thing with requests, you import requests, you have your username and password, and you make a request, and you get your response. And that's it. Yes. Achievement unlocked. We have a small set of methods with consistent parameters, one for get, one for post, push, delete, all the rest. And they all accept headers, parameters, URL parameters, body, and form data. That wasn't so hard now, was it? Do this. Do this for everything. The litmus test is if you have to refer to the documentation every time you use a module, find or build a new module. And to do this, I like to say that you need to fit the 90% use case. Basically, it's really easy to get hung over on people that are like, you're going to try to solve the problem for you and for the 90% use case. And there's going to be this other 10% of people who are going to complain that the API doesn't fit their use case. It's, they have this weird thing that they do at work behind like 17 proxy servers. And your library doesn't suit their needs, and it's terrible, and no one should ever use it. And it's really important to learn how to ignore those people, basically. There's lower level APIs that can be available to suit those people, but that's not what the 90% pragmatic Python for humans package is. The API is really all that matters, and everything else is secondary. And I mean everything. Features, efficiency, performance, corner cases, all these things are really important, but for a package like this, they are not as important as the API. So to do this, what I do is I write the README before I write any code. Actually sit down and I think about what I want this library to do, and then I actually try to write some code with it as if it already existed. So I'll be like, import my library, and then I start using it, and I say what the result is, and I go through all these steps, and then I go back and I try to do all the steps, I write all the code to make that possible. So with requests, I did this, and at first it worked, but it was really far from powerful. It wasn't very well architected internally, but it really resonated with a lot of people, and the features grew over time, and the API was never compromised. So today, it supports cookies, sessions, content iteration, decompression, all this crazy, awesome stuff, OAuth, connection pooling, like really advanced things that all the other libraries don't do. And the API is still as simple as it was originally. And it's been downloaded over 3 million times, and a lot of really great companies and organizations use it. So cool story, bro. Why am I telling you all this? Basically, the moral of the story is that it's obvious that people need APIs like this. If you're going to build something like this, people are going to be using them. And it's the success of this library shows that there's a real hunger for libraries that are easier to use. So if you take your time to build something like this as a developer, it'll definitely be worthwhile. And if you can save 5 minutes of one developer's time for yourself, think of, if you're saving 10,000 developers 5 minutes time, that makes a big difference. So that was the HTTP version of the different barriers to entry in the Python ecosystem. And now I'm going to go over some of the more general barriers to entry that I've noticed and that I've talked to from people who teach Python a lot, things that kind of bother me, and things we can do to fix them. So first one, this one drives me crazy, file and system operations in Python. If you ever have to interact with a system, there are like 7 different modules that magical function or method that you're looking for could exist in. And you have to Google every time to figure out which one it is. At least I do. There's sys, shutils, os, os.path, and io. And that thing that you're looking for can be in any of them. And that really sucks. And it's really difficult to run external commands in Python as well. There's a subprocess module, which is great, but it just kind of bubbles up the C API. And it has if you look at the actual documentation, it's kind of crazy. There's I believe 19 different parameters to the main class, and it doesn't really tell you what any of them do or what the effects of them are. And that sucks, because if you look at a language like Ruby, they make running commands, external commands, really easy. And I think that's a big reason that people are building all these system utilities and DevOps tools in Ruby and not in Python. Installing Python. So who here has installed Python on a Mac? All right, who has installed it with Homebrew? Who uses the system Python? Who uses the one from MacPorts or Fink? Who built it from source? And who installed it from python.org? All right, so what happened to there being only one obvious way to do it? The very most fundamental thing that we do as language users is install the language, and even that is something that is not, there's no obvious way to do it. It really sucks. It's terrible. So you have to decide if you're using Python 2 or 3 right now. I think that's going to get you a lot easier soon, but it'll get worse before it gets better. You have to decide if you want 32-bit or 64-bit. If you're building for the Mac, you need to decide if you want a Unix or a framework build. It's a very poorly documented thing. So there should be one, and preferably only one obvious way to do it. XML hell. eTree is very frustrating to a lot of people. LXML is a really great library, but it can be difficult to install a lot of the times, and the error messages you get when trying to install different libraries that have C extensions they leave something to be desired. LXML actually does something really cool. If some of the libraries that it needs aren't available, it actually will get them itself and statically compile itself against them, which is something that I like to see a lot of other libraries start to do. So if you're using the system Python on a Mac, you'll notice that there's this easy install command available, and you start using it, and everything's great. And then what you don't realize, if that's your first interaction with Python, that's easy install isn't available. It's not built into Python at all. That's something that Apple put into their Python. That's something that you normally have to install. So that's like an unobvious barrier to entry. You have to decide right now if you need to use pip or easy install. If you are using easy install, there's no easy uninstall, which sucks. Setup tools appears to be built into Python when you're using it on the Mac, as I said. Let's see here. And people often release packages onto the C shop, or they don't release them onto the C shop, but they say they're released. So they're like, to use our library, just do pip install, git plus git, github.com / their library. And that's unfortunate. but it's getting better. Date times, these ones are fun. So, if you're trying to do something with dates, you have to figure out which module you want to use. There's a date time calendar libraries. If you pip install dateutil on Python 2, when you import it, it will fail because it installed the Python 3 version, unless you explicitly say you want version 1.5, which is unfortunate. Time zones, I'm just going to skip that one. Of course, everyone should just use UTC all the time, and then everything goes away. And the standard library can generate but not parse ISO 8601 dates. Unicode. Oops. Yeah, Unicode. That's a really big one. I think that this is getting better. But what was that? Thanks to Ned. But it's a big barrier to entry. I think better docs will help. We'll skip that one. Testing. There are many testing libraries and runners available. I know in Python 3 they just added a new test runner thing. I haven't looked at it too closely, but that should help. But there's right now, if you want to run unit tests, you can use Nose, you can use py.test. There's a bunch of other ones that will run them for you, but it's unobvious which one is best and for what uses. A big thing that I notice people doing is they find doctest, which is really great for testing things locally, it's great for testing if your documentation is correct, or it's good for testing a little script that you wrote. But people will build very robust applications, and they'll use doctest as their only form of tests, which leads to pretty poor tests. So it should be in the documentation, what suitable uses of this library are for. Installing dependencies. The Python MySQL library, this one gives me a headache every time I try to install it. I can never remember the name of it, because there's Python MySQL or Python MySQL DB or DB-lib MySQL Python something. My solution to that is to just use Postgres instead. I don't have to worry about it. The Python imaging library has a lot of problems being installed for a lot of people. If you're on a Mac, it's 2 commands away for having it install perfectly. You just have to brew install the PNG library and the JPEG library, and then suddenly everything works. But getting that far is it's not in the documentation, and you're going to get these weird errors when you try to install things, and it sucks. If you're using ModWizgy, you have a lot of people use ModWizgy, and it's fantastic. But what happens when they're using it, say, on an Ubuntu system is they often don't understand how installation of it works, and they'll just kind of use the one that's available in apt-get. And then what happens is they don't know what version of Python they're running, and they don't feel they have the control to even modify it if they do. So I've gone to a lot of companies where I start to work and help them with their code base, and I'll be like, so what version of Python are you guys using? And they have no idea. They're just like, I use the one that comes with, the one that comes with ModWizgy. Which is unfortunate. So I think that focusing more on decoupling those things is beneficial for everybody. So my solution to these problems, my attempt to help, is called The Hitchhiker's Guide to Python. It's available at python-guide.org. And of course, it teaches you to don't panic and always carry a towel. Basically what it does is it documents all of our best practices. As we learn the language of Python and as we become more ingrained into the culture and the ecosystem, there's a lot of tribal knowledge that we learn. And I'm trying to basically serialize as much of that as possible, because these things should be written down, they should be documented. So if you're a newcomer to Python, you don't have to spend those years trying to get all this knowledge out. It should be written down somewhere. This will ideally be a place where people can go to get that. And if you're a seasoned veteran, let's say you've been doing scientific computing for 10 years and you want to switch to web development, you still have to go through that tribal knowledge phase. So ideally, you'll be able to come to this, and it'll just tell you the frameworks that are available that you should be using. It'll be opinionated, and everything will be a lot better. So it'll recommend distribute and pip virtual env out of the box, and it'll have explicit installation directions for every operating system. It'll instill resistance to doctest and teach everyone to use datetime.utc now instead of .now, and save everyone a lot of headaches. So I'm hoping that everyone in the room here who has any experience with Python in any way, and I saw your hands before, there's a lot of you, will send pull requests to this project, because we all have different aspects and we know the different things that we run into that causes problems, and that's the only way to get all this tribal knowledge out of our brains. So if you go to the GitHub repo, you go to the website, there's a little fork button in the corner. Basically, if it's a good change, and I think I've only rejected like 2 pull requests ever out of like several hundred to it, I'll merge it in, and it'll be live on the site within like 10 seconds. So if you do that, just remember there's only one rule, and it's that there should be one, and preferably only one, obvious way to do it. This makes Python more accessible, lowers the barrier to entry, it sets developers on the right path, and it allows us to practice what we preach. So, the manifesto of the talk is simplify terrible APIs and document our best practices. Any questions? Yes?
So, one thing I've always been really curious about with your requests library is that I believe it's built on top of URL lib2.
It used to be.
It used to be.
Yes, originally it was, and it was the worst thing ever.
That's what I was curious about. My question was, how do you decide when to build on top of core APIs, and how do you decide when to try to circumvent them entirely?
So the original plan for it was basically, I wasn't intimately familiar with all of the aspects of HTTP. So I basically was trying to build, like I thought of, here's the API I want for this other thing. And I just kind of had to become intimately familiar with urllib2 to get it to do what I wanted. And I just started scripting it. And it became very troublesome very quickly. And it became shockingly obvious that it was a huge problem. Because like someone would be trying to send like a HTTP digest request, and like with certain response codes it wouldn't get, and all this stuff was happening that there was no code for in my code base, and I couldn't find code for it in urllib2 either. And it became very obvious that it wasn't helping at all. So I went back and I implemented it all in HTTP lib, and my life became tremendously easier, basically. So I don't know. I think ideally you should be able to try to implement it in something, prototype it. And it should be pretty obvious if it's a good idea or not. Especially as new features get added, it should become pretty obvious how flexible the architecture is. And that was the big thing for me. It was the architecture was so horrendous that it was like impossible for me to add very simple features. And I think I learned a lot that way. Did that answer your question? Awesome.
Thoughts on the unit test module specifically? Like you talked about, there's all these different test runners.
Mm-hmm.
But when you're in the module, it's very like Java-like. It's very weird. There's a lot of strange things like what's a test result, what's all these different hierarchies of runners and stuff like that. Do you have any suggestions or thoughts on what to do about that library?
I think it's the status quo, and my opinion at the moment is that everybody use it. I actually started a fork of it for fun. It was called unit_test, and it was just a PEP8 version of it. It just, it wasn't the, camel case basically. But it was a waste of time, so I didn't do it. But I think there's a lot of work that could be done there. I really do like what py.test does. It'll just take assert statements and turn them into, it'll make more proper exceptions out of them, which is really cool. But I just found out that if you do the -00, you do the optimized, I think that's what it stands for, flag to Python, it just like skips asserts all the time. Like that's supposed to be more efficient, which is the worst thing ever. So assert statements as syntax apparently aren't something that you should be doing. I do them all the time though. So I think they're going to remove it in Python. But yeah, I don't know.
Remove what?
So is it it's the optimized flag for Python. It skips.
It'll skip the search statements, right?
Yeah.
Yeah. File them out.
Which is like I use them for control flow. A lot of people do.
Don't run with the optimized flag.
I don't. I mean, I know. Exactly. I never have. I think someone's going to fix it, so it just takes out the doc strings and keeps the asserts. I think that was what the discussion was.
I'd be very surprised if that happened.
At least on Twitter, I didn't see the mailing lists. I avoid mailing lists. Yes.
What is the one obvious way to debug Python
Ooh.
code?
Kenneth, repeat the question.
What is the one obvious way to debug Python code? And I'll give you my honest answer, which is the wrong one for everybody, but it's the print statement. Yes. Although in Python 3 it gets harder because you have to put 2 extra parentheses around it, and it drives me insane. I'll get used to it eventually.
You haven't tried PUDB yet? PUDB. Yeah, it's like PDB. It's got the same commands, but it's character mode full screen, so you can see your code with a line going up and down instead of printing out statements as it goes.
That's better. Can you patch?
Can I? No. Why would you want to do that? That's insane.
Yes.
Do you have any advice on installation and configuration of third-party things? The example I would use was, I just was doing a project with OpenCV, and there's 6 million optional dependencies, JPEG libraries and MPEG, this, and if some of them aren't working, some of the code doesn't work, and if they do want to get them all there, there's about 1 million apt-get statements, sometimes with changing package names and so on.
Yeah.
Is there a way to make that easier?
Today, I don't think so. I think this is actually one of the most difficult, like, unsolved problems in at least my world. It's just like system dependencies and declaring them, not just for Python, but for anything. Like at Heroku, it's really difficult for us to, like, if you want to have an obscure system dependency, you have to just basically make a tarball of it and like write a script that extracts it, which sucks. Like, there should be a real way to do that, but I'm not aware of anything to do that today, other than just relying, marrying a certain packaging system. Although in distutils 2, there's a new directive called requires external, and it doesn't actually do anything on its own. It's just a metadata slot, and it basically, the thought is that you could just have strings in there, and then ideally you could have something that maps those to whatever system you're using. So you could just have like OpenCV version whatever, and then it would extract how to install that from that. But I haven't seen anybody do that yet. I think that is the path we will go down, but it's kind of unclear still. I've heard really good things about the Nix package manager as well, NIX, which is like, I know a lot of Clojure people really like it because it's like a Lisp type of thing, functional package manager. But I don't know a whole lot about it. But those are the things that I know we've explored internally, and that I'd love to see people start working on that more because it affects everybody, and it's something that we never talk about. So, yeah. Yes.
I guess maybe I don't fall in the 90% use case, but I'm wondering if you've thought about ways of supporting either more hooks or ways of swapping in alternate implementations of the things that a request object uses, like your own dict-like object for headers. Or,
Yes.
I know PyCurl lets you provide like file-like objects for reading and writing requests and response bodies.
So a big challenge is I was trying to improve the API and remove functionality. I used to have like a lot of hooks. Like there was like 4 of them, I believe, different types that it would basically call back. That it would use if they were provided. And no one ended up using a lot of them, so I removed them, and I came up with a better system, I think, called connection adapters, which basically it's like a class you define, and all it does is it defines the entire way to take a request object and return a response. So the whole flow could be done completely. You can override all of it. So ideally you could have just a bucket of files in a directory and pretend that it's a GET request. And that it actually did HTTP, and that's the goal. It's in the documentation now, and people are using it for some cool stuff. But I haven't. It's not something I pushed a whole lot yet because it's kind of experimental still. But do you think that would solve your use case?
That sounds like it.
Okay. Yeah. Absolutely. Yes.
By chance, do you have an example of post request? You had something very simple.
Yes.
Just something more XML-like, how you parse things, how you get them back.
So the question is how to do an example of a post request.
Post request and response.
Let me I'll pull the documentation up.
You can minimize this guy.
Oh yeah, that's probably great. I have my IRC stuff popping up now. No. How do you turn this? There we go. All right, cool. So here's an example of a post request. Basically, what I do is I have it so if you you can provide a dictionary, which is the most common, I think, way of thinking about post data, and it'll automatically encode it with URL encoding and do the post for you, or not URL encoding, whatever they call it. It's been a while since I've looked at that code. But you can also provide a string, or a byte string, or a file-like object, and it'll stream it up automatically. So that is the way you do a post. And then when you actually get the response, there's this r.text. That's the Unicode representation of that object, the response. And there's also r.content, and that is the bytes version of it. So, and that's the same on Python 2 and Python 3. And it works pretty well. I also implemented a way for you to, it's undocumented at the moment, but if you have some really crazy post requests for like streaming uploads, you can define this basically this class, and it will tell it how to encode it as it's uploading. So if you wanted to have a long streaming upload, you could. Like, you know, you have something coming from a video stream or something like that, you could perpetually upload it with that. But almost no one, I'm waiting until someone asks for it before I actually document it, because it's kind of crazy. That's a good way for me to determine if something's worthwhile. Like, I'll be implementing something, and I'll think of this weird use case where, you know, it'll break for somebody. And I basically just wait to see if anyone says anything. And it'll take, like, this happened actually a couple weeks ago. Like, I waited, it took like 3 months for someone to ask about the thing that I was thinking of. So we solved it when he asked. But it worked out really well. I did it for my blog too. I re-implemented my blog recently. And I didn't bother building RSS feeds. And it took 2 months for someone to notice. So I determined it was a bad thing to spend my time on. So, yes?
But what I was specifically curious about was, in regards to the executable builders like ITC, would you basically bless Endeavor to kind of clean up that area in regards to your philosophy, or are you kind of on the camp of no, this is the way of creating a desktop application?
So the question was, what is my stance on tools like Py.exe? And my personal stance is that they are fantastic, and they are terribly implemented, and the worst thing ever to work with. I actually had like a full-time job for like a year of like, I had this PyQt application that I built, and I was trying to build it with completely portable executables for Python, or sorry, for Linux, Windows, and OS X. And it was the bane of my existence. Because they all kind of like use setup.py as their framework for execution, and bootstrapping, which is like a terrible idea, because when you're trying to use them at the same time, they all do things differently and they interfere with each other. I think that portable executables is fantastic, and if you're going to be building anything for users, you know, an actual like consumable application, then you know, I think that's the target, right? Like, why would it be anything else? So I really hope more people start building things like that. I think that there's a tremendous amount of work that needs to be done there, because it's super frustrating. I actually talked to the guys at Dropbox. Most people don't know this, but the entire Dropbox client is written in Python, and it's using these build tools. But basically, like, for them to get it to work, they just have like a guy who I met at PyCon. He's really cool, but he like maintains that, and like if he gets hit by a bus, they'll never be able to change it, because it's like the worst thing ever. And like, I actually asked him how he got around certain things, and he's like, "Oh, I have no idea. It just didn't get, you know." So he has to. It's just the worst. So I really hope things improve there. I was hoping that PyPy actually, since they have I think a better architected core, I think they might be able to add that pretty easily. I've seen it come up in a mailing list before, but I'm not sure. But yeah. Yes.
If anyone else wants to build portable executables, I find PyInstaller much better than Py2exe and Py2app. PyInstaller is good, and it's a good mailing list where I might answer your questions if you ask them.
Excellent. Yeah, I agree that PyInstaller is, if you're building for the Mac, it's the only one that actually builds them as a Unix executable instead of as a bundle thing like a .app, which is really great. When I was doing it, I ended up doing Py.exe for Windows and then PyInstaller for the other two, and then ignored things like bbfreeze and cxfreeze and freeze. But yeah, yes?
So, you're pretty active with the Flask project.
Mm-hmm.
And I wonder if you feel like Flask
The question was, do I see Flask as web application development for humans or something else? I think it depends on what your definition of web application development is. For me, I think that it absolutely is that, but I really think that Flask is HTTP servers for humans, basically. Because basically what you're doing is you're crafting responses and responding to them with simple routes. That's really all Flask is, as opposed to enforcing some kind of architecture or some way of thinking about your code. So for me, it definitely is. But I try to stay in the web services realm as much as possible. I know a lot of people really like the way Django does things. I'm not one of those people, but I do like the way Django does things. If I'm going to build something, I usually try to build a web service before anything else. So. I think, so for me, for the Python guide, the two things I recommend are Django and Flask, basically. I think those should fit almost all of your use cases. Obviously there's tremendously more, but those should be the obvious first picks. I don't think a person who's just getting into Python should dive into Twisted to write an MVC app, but maybe they should, I don't know.
Will it support Python 3 eventually, Flask?
Yeah, they're working on it this weekend, actually. The question was, is Flask going to support Python 3? I'm good friends with Armin, and he has been very much on a triad against Python 3. He actually didn't come to PyCon this year because he didn't want to spoil everyone's party by complaining about Python 3 the whole time. But I think he's finally coming to terms with the fact that it's happening. And he just wrote a blog post today or yesterday about he ported Jinja 2 to Python 3. A couple years ago, and it was actually broken for a year and no one noticed, which was a big testament to him of why this is a big waste of time for him at the time. But basically the port was done poorly, and it was like a big fork. I think there was 2 versions of the code base inside one repo, and it was ugly, and now everyone's kind of developed a better way to support both at the same time. And now I think he just had a hackathon last weekend in London to port it properly, and it's done now. And the blog post is the big lessons learned, and I think Flask is next on the board. So I'm really excited to see that happen, because if it didn't, I was going to be very upset. I actually told him if he wasn't going to do it, that as much as I'd hate to spend that much time on that, I would have done the work, because WorkZoga is really complicated, and I usually try to stay at the higher level things. But I offered to dive in head first if I had to, but he's doing it now, so I'm very, very hopeful. Yes?
So what would be the one obvious way to structure where your test directories are with respect to a package hierarchy? Maybe the context would help a little bit here, is that we have a monolithic web service, and we're breaking it down into a framework for a very thin level web service, so we can tie in a web app and another web service on top of it.
Mm-hmm. So
the kind of namespace too with the test directory.
Yeah, I know exactly what you're talking about. So my traditional suggestion to people and recommendation is that at first I just have a file called test_libraryname.py, and I put all my tests in there, and it's above the package. So let's say it's at the root of the repository. You have the package available at this real package name in the repo, and I have test package name.py. And then you can import it regularly and everything works without doing any module hacking and path hacking. Mm-hmm. But obviously when you have more than 20 tests, you want to break them out into files. So then what I personally do is I create a tests directory at that same level, and I start putting them in there, and then I'll do the path hack, basically.
Is this in Python guide?
I wrote a blog post about it, and I said I was going to put it into the guide, because it's for the guide. I don't remember if it's in yet. I think it is, though.
Right.
Let's find out.
While you're looking it up, the hack that I did is I just added an in the test directory that all the tests would have.
Oh, yeah. Sorry. I'm happy that I did it, because I wasn't sure. Did I do tests? I even used the same number, 20 tests. That's good.
All right, awesome.
At least I'm consistent. Sorry, what were you saying?
No, I was just...
Now, I feel like if you're using a Django thing and there's a lot of sub-packages that are portable, I feel this isn't I don't think this suits every need. But I think it's a good first shot, basically, because it gets really complicated, and it's unfortunate that it gets so complicated, but I think. So I need to double check, but I believe that there's something in Python 3.3 that allows you to basically, there's like a test discovery functionality that's in there now.
The unit test has that in 2.7 and in 3.3.
Okay, yeah, that's what it is.
Or like nose?
Yeah, but it makes it part of the standard library instead of just kind of everyone doing their own thing. So I think that'll help a lot.
Thank you.
Yeah, and they just added it in Django as well, their own thing for defining that. Because before it was just kind of like everyone does their own thing, and it was super complicated. So yeah, yes.
How do you convince people to write documentation?
Ooh. I force them to use my code. In what context?
I've been in many projects where like there's a lot of stuff going on in the code base and things are constantly shifting underneath your feet, and I'm constantly wishing for documentation. Or even on the other side of that, where I'm making lots of changes that I know other people are going to want documentation for, but I don't know what's a good place to put it or a good way to write it, I suppose. So I'm wondering if you have any recommendations for the one true way of doing it.
I feel like the best thing for me is to try to write documentation. I'm going to say that's not true. Hang on. I was going to say the best thing to do is write documentation before you write the functionality. But I don't actually end up doing that all the time. So I don't know. It depends. I feel like if you have really nice. Okay, this is gonna sound weird, but this is really what I believe. I feel like if you have really beautiful docs, like really nice theme with the docs, and it's really easy to build. It doesn't take any work. Like they just kind of add the code and it's there. It really encourages me to start writing docs because it's like I'm starting to build towards this really nice, thing I'm proud of, as opposed to just like this thing I'm typing in my basement at night and it's boring. I don't know. That's just me though. I don't know if everyone's like that or not. But that really helps a lot. Like I don't want to write a blog post on a blog that looks ugly. Like if it looks really nice, it inspires me to actually do the work to do that. So I don't know. Is that a good answer? I feel like that was a terrible answer.
The answer is get a typographer.
Or find a great Sphinx theme. Like that's really what it is for me personally, and then making it just as easy as possible for the docs. Like just slap the doc build into CI, and have everyone access it constantly. And I feel like they're not going to be, if they're good, people will start using them and they'll rely on them, and then they'll want to improve them. If there's nothing there yet, you kind of, that's something that there's a change that needs to take place first before that'll happen. Yes.
Hi. I have a question. I started to use Python recently, and I was surprised that there are like Python 2 and Python 3, and it's like two different beasts.
Yes.
And they actually exist in separate branches, and they're not going actually like to merge, or one is going to die. I mean, this is actually the first time in my life I saw some language that actually does not support the old version, or you can switch to another version, and the first release is actually like deprecated. What is the idea behind these two parallel universes?
So the question is, what's the difference between Python 2 and Python 3, and why it's necessary?
I guess the question like life cycle. Is it supposed to be like this forever? I mean, what is the idea there?
So currently what happens is that there's Python 2, which is basically what everyone's using on a day-to-day basis. And there's Python 3, which has existed for like 5 or 6 years now, which has only this year become considered production ready. And it's taken a while because it needs to be built, it needs to be tested, and there's so many changes to the language that it's hard and unobvious what needs to be improved for it to be production ready. So now with Python 3.3 as it's been released, the stamp of production ready from the Python core team has been applied, and now people are going to start using both. And it's going to be, I think it's going to get a lot worse before it gets a lot better, because right now it's pretty obvious to use 2 unless you can use 3. But in the next 2 years, it's going to be they're going to have a lot of libraries that only work on one and not the other. And the only way really is for people to just support 3 as fast as possible. And all the mainstream libraries are doing that. And as soon as everyone else, in another year, I'd say, people will be using 3 a whole lot more than they are now. And then it'll be, oh, go ahead.
To address your question about why there are both, after 20 years or so of development of Python 2, there were a number of things in the language that they didn't like anymore, and they wanted to break backwards compatibility in order to improve the language. And so they took the break from Python 2 to Python 3 to make the improvements in the language. Python 2 is going to be around for a really long time. There will probably be, they just released 2.7.5 this week. There'll probably be a 2.76, and a 7.7, and a 7.8 as they fix bugs, but they're not going to add any more new features to 2.7. So Python 2 feature has ended. Important fixes will go in, but all the new feature work is going into Python 3.
Okay, let me ask you this. For example, Kenneth complained that in Python 3, he can't use his whole string with space. He has to put parentheses around.
That's right.
Is it supposed to be improvement?
It's an improvement.
It is an
Now
improvement,
print
yeah.
is a function, which means that you can change how it behaves. And it means when they want to add features to it, they don't have to invent wacky syntax like they did in Python 2.
Basically,
So
print was a
Python
hack before.
Right. In Python 2, to print to a file, they invented syntax of greater than, file, comma.
It was a bitwise shift, right?
It just,
Obviously.
there's no need for print to be a statement. It's a function.
Okay.
Yeah.
I mean,
I'm just complaining because I'm so used to Python 2,
The
basically.
good news is you can stick with Python 2. It's going to be a long time before stuff shows up that only works on Python 3, although that will happen.
I actually have a theory that Python...
Because they don't want, the language won't move forward.
The language will move forward. You won't.
I have a theory that Python 2.7 is going to be the most modern stable language in history, basically. Because it will never be modified, and it's definitely the most modern out of those. So if you're going to build something for real, true long-term stability, build it for Python 2.7.
Actually, this gets an interesting, one of the questions from the RSVPs. On your slides, you started with an example of how Ruby is nice and clean, and how Python was ugly and you had to make requests in order to make it pretty again. Why use Python?
Because Python has PEP 20. Because Python's awesome. I feel like that, so Python is normally awesome, and Python's normally very clean and pretty. And I'm basically just trying to show where that isn't consistent. And that's the big thing for me. Is Python in general is fantastic, and it's by far the best language for me. And I guess I should make that more clear in my talk. Yeah. Yes.
So one of the things that you stressed in your talk was that you'd like to focus on the 90% case as opposed to the 10% case. So when you were developing features, when you're developing a new framework, there's clearly a lot of 30% cases, 50%, like a lot of things. There's the obvious 10% case and the obvious 90% case. What was your criteria for drawing the line between, what was getting overly complicated and wait for it versus what we're just going to go into the first release?
For me in particular, it was a difficult thing to figure out. It was something I changed over time as well. So I did add features that have been removed since. With the 1.0 release, I removed some, like for example, when you do a post request and there's a redirect on it, the RFC says that if you're going to follow it up, you have to, basically the user has to authorize it, and then it'll follow it up with another post request. Every browser in the world does a GET request instead of a post request. So I added a strict mode that was, I think, enabled by default. And so like there was this forking that was happening, this branching in the logic, where he's like, if strict mode, do it properly. If not, then do it the way browsers do. And eventually, I just kind of figured out that I try to avoid that situation at all now. So now it just does what the browsers do, because no one wants it to be any other way, basically. And if they do, they can just turn off redirects and do it themselves. And that's something that really took a long time to figure out. And I think it's different for every project and every library. The thing that I've really learned the most is how to say no, basically. It was really, really important to say no to a lot of features that people ask, because people ask for a lot of things. And they're going to ask for things that seem reasonable and things that seem unreasonable. And the things that seem reasonable can be deceptively complex. And that's basically, I try to, if anything's going to add code that seems unnecessary, I try to say no now. But it's because it's pretty mature. So I think it really depends on the project and the maturity level and the goals of the project. But I think that's like half the battle, basically, of maintaining a project, is trying to figure out where that line draws.
It sounds like in a way you kind of, it sounds like in a way you were utilizing the fact you have an open source project, you can kind of just listen to your users basically and adapt things based on what their usage pattern was.
Yeah, it's more of like a product design type of thing. I actually just did a talk about this last week. It's called Growing Open Source Seeds, and I kind of went over the different styles of projects. Basically, I said that there are public source projects, which is like a company like Facebook releasing their SDK publicly, but like it's not really open source. You know, there's like 1,000 issues open. No one's going to comment on any of them. And then you have things that are very like open investments, which is like GitTip or Django or Python, where all the decisions are kind of shared between everybody. And it's like this really important project that people rely on, and the goal is to affect, change the world. And then you have projects like Requests, which I call a dictatorship project, which is basically me making all the decisions. And I'll listen to everybody, but I listen to everybody and then disregard it and try to make the best decision myself, as opposed to getting a lot of other people involved in the decision-making process. Because I think the value of at least this project is the opinions that it has, and if you have a lot of other people involved, I think it'll dilute it. And I think the dictatorship is what makes that possible.
But on that theme, you said that you only have rejected 2 pull requests out of hundreds.
That was Python guide, not requests.
Python guide.
No.
Okay.
Yeah, with requests, I've rejected thousands. Probably only 500. But yeah, I also try to be as positive and what's the word? Well, no, when someone sends, I try to be as very thankful and positive as possible and encouraging, even if I don't accept it. I tell them why, and I encourage them to send more. It's not like I don't want people to contribute. I definitely do. It's just, it's complicated. Yes.
So you mentioned a couple times about features that you've added in, and then later decided to take out. And so I guess the question there for me is, at what point do you decide that, hey, this is a feature that's not being used, I should remove it, or hey, this is a feature that's not being used, I'm just going to leave it here for the people who do? Because there's certainly a point where you want to keep the code clean and documented and such, but there's also kind of that point of some people might be using this. Do I really want to take that away from them? Like, how do you strike that balance?
So for me, it was really, I did that, and I had some people complain. I asked for feedback, and I got a little bit, but not a whole lot. And then, of course, the people who really cared weren't online at the moment when I asked, and they all the pitchforks and stuff get raised. I don't know. I think it's something I had to you just got to go with your gut, I guess. Is really my answer. Ideally, having data is the best case scenario, but with open source projects, you usually don't have that.
One way to help is if it has tests, it has a prayer of not being broken, so then maybe it's worth keeping.
Yeah, if you have to remove tests, that's usually a bad sign. Unless it's a crazy, crazy test.
Let's take 2 more questions.
Yes.
Speaking about tests, I noticed how you said that you normally start with the README and you go introducing the code from the README. So how best would you say to incorporate like tests into your workflow, especially with the advent of like test-driven development and behavior-driven development? How do those correspond to like using Python?
So I consider this API-driven development, and I think a really good way to enforce that is to basically, if you're going to write, you can write your README with all your things, and then write tests for each of those examples, and then start building it that way. But that's not test-driven development. It's just kind of like tacking it on to this other thing. So it's, I think you can definitely do both at the same time. So for the README thing, that was just for coming up with the initial API, not for the lower level stuff. So if you're doing real TDD, and you're like writing really good unit tests, every tiny little backend thing, it's not the porcelain API that the users are using should be tested as well. So those two can totally exist at the same time.
Eddie, last question?
Sure. What's the best, most obvious way to provide like a stir or a wrapper for an object?
Ooh, by writing the repr method.
Every project like has a different format or whatever, or what it actually helps with.
I guess mine always look like the brackets and then the name of the object, and I have to do the ID thing. It's like, is it %D or something? I don't know. The hex represent where the memory location is.
Yeah, ID?
Yeah.
ID we could do.
Well, yeah.
Percent.
But there's a percent
there?
value. Yeah, there. See, exactly.
Look it up.
Yeah, anyway.
It's like there's
Yeah.
some-
Yeah, percent X.
like, you
That's
can,
it.
like, recreate the object with that. Is that something you should strive for? Or?
Ooh, I don't think so. But actually, so it turns out that the language that Python was based on, which I can't remember the name of, ABC, that was actually like its core feature, which is super awesome. But I don't think that really works in a modern world anymore. But I like the concept. So basically what I try to do is if it's representing a dictionary, I'll try to put the value in there, unless it's the actual keys and values. But in the ideal world, you're not supposed to treat dictionaries that way. You're supposed to treat them as if they you don't know how many, they could be n-sized. So I don't know. It's kind of tricky. I think basically all of mine look the same. I'll just I'll make them look like the built-ins that you see, but it's, I don't know. It depends. Good question.
All right.
All right.
Thank you,
Thank you.
Kenneth. Now,